Your test tomorrow, which is on 5-1 to 5-3, is 15 questions. It's literally fair game from anything from 5-1 to 5-3. It is very similar to your review. If we look at the first part, we're just simplifying and we're keeping our answers with positive exponents. So your answers have to have positive exponents. Remember with these, if a number is raised to a power of 0, it turns that number or that base to be 1. If there's a negative in front of a number and that number is raised to a power, if the negative is not in parentheses, it's not a part of that number. So that negative is not being raised to the power. It's only if that negative is inside the parentheses and the parentheses is raised to a power that that negative is raised to the power as well. If you are multiplying and you have the same base, add your powers. If you are dividing and you have the same base, subtract your powers. If you have a power raised to a power, multiply the powers. If we look at number 1, we have -2 to the 4th power. This is also the opposite of 2 to the 4th power. It is not like number 3 where you have the -2 in parentheses. So this, if it makes things easier for you, put parentheses around the 2 to the 4th power. 2 to the 4th power is 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's the opposite of 16, which is -16. So again, this is different than number 3 because number 3, you have a -2 raised to the -4th power. Not just because the power is negative, but because the negative is in the parentheses with the 2. So that's like saying -2 times itself the 4 times. However, that is a -4, so put it in the reciprocal. It would be 1 over 2, which is negative, raised to the positive 4th power. So this is just a positive 1 over 16. So you got to be careful with those. So 2 things there. The negative that's in the parentheses and the negative power. So the negative that's in the parentheses, since it's in the parentheses, it's raised to that power as well. The power is negative, so you take the reciprocal of the term that's attached to. If we backtrack to number 2, you have the opposite of 2 to the power of 0 times 5 to the -2nd power times 5 to the 1st power. This negative, or this opposite of 2 to the power of 0, again, the 2 is the only thing that's being raised to that power of 0. So it's like saying the opposite of 1 times 5 to the -2nd times 5 to the 1st. So you can add those powers. The opposite of 1 is -1 times 5 to the -1st gives us -1 times 1 over 5, which is just -1/5.
Wait, how did you do that again?
So we ended up changing the 2 to the power of 0 into be 1. Because that's the only thing that's raised to the power of 0 is the 2, not the negative that's in front of it. From there, we took the opposite of that, which is -1. Then you have the 5 to the -2nd power times 5 to the 1st power. Your base is the same, which is the 5, so you can add your powers. And the -2 plus 1 gives us -1. So it's 5 to the -1st power, which is 1/5.
Oh, okay.
So then we're just multiplying the -1 times the 1/5, which is -1/5. For number 4, you have x to the 3rd power times x squared times x. That x that does not have a power on it, it's understood that the power is 1. So our rule when we're multiplying, if the base is the same, you keep the base and add the powers. So we're going to do x to the power of 3 plus the 2nd power plus the 1st power, which 3 plus 2 plus 1 is 6. So that's x to the power of 6. For number 5, we have a to the power of 9, b squared over a squared b to the -3rd power. If you would like to take care of your negative power first, that negative power will turn into a positive if you bring it to the top of that fraction. So this would give you a to the 9th power over a squared with b squared and b to the 3rd power up top. Your rule, when you are subtracting or when you're dividing two bases that are the same and they're raised to powers, keep the base, subtract the powers. If you're multiplying and the base is the same, keep the base, add your powers. So a to the 9 minus the 2nd power is a to the 7th power. Then b to the 2nd power plus the 3rd power is b to the 5th power. So it's just a to the 7th power, b to the 5th power. For number 6, we have 2a to the negative 5th power, b cubed, all raised to the 5th power. So this is the same exact thing as saying 2b cubed over a to the 5th power, all raised to the 5th power. The only thing that has that negative power on it is the a. So that's the only term that you're taking the reciprocal of. So from here, we're going to raise the top of this fraction and the bottom of this fraction to the 5th power. 2 to the 5th power is 32. B cubed to the 5th power, we multiply those powers, so that's b to the 15th power. Over a to the 5th power, raised to the 5th power is a to the 25th power. So this just gives you 32b to the 15th power over a to the 25th power. For number 7, we have ab to the negative 6th power over a to the 7th power, b to the 4th power, all raised to the 3rd power. Simplify what's inside the parentheses first. That a over a to the 7th is like saying a to the 1st minus the 7th power. Then that b to the negative 6th over b to the 4th is like saying b to the negative 6th over, minus 4. And then this is all raised to the 3rd power. This is going to give you a to the negative 6th power, b to the negative 10th power, all raised to the 3rd power. If we turn those negative powers into positive powers, this becomes 1 over a to the 6th power, b to the 10th power, all raised to the 3rd power. When we have a power raised to a power, we multiply those powers. So it's just 1 over a to the 18th power, b to the 30th power. For number 8, we have 2xy to the negative 3rd power squared times 3x cubed y to the negative 4th power, all raised to the negative 3rd power. If we simplify what's inside first, this is going to give us 2x over y to the 3rd power squared times 3x cubed over y to the 4th power raised to the negative 3rd power. This then becomes, if we distribute in that 2 as the power to the top and the bottom of the fraction of the first one, we're going to get 4x to the 2nd power over y to the 6th power. If we turn that negative 3 into a positive 3 power on the second set of parentheses, we're going to have y to the 4th power over 3x cubed, now raised to the positive 3rd power. So this gives us 4x squared over y to the 6th power times, we're raising each the numerator and the denominator of that y to the 4th power over 3x cubed to the 3rd power. It's going to give us y to the 12th power over 3 to the 3rd power is 27. X to the 3rd power raised to the 3rd power is x to the 9th power. So we're just going to multiply these straight across. When we multiply them straight across, remember, if you have the same base on the top and the bottom of your fraction, you're going to have to subtract those powers and make sure that it's positive in the end. So we're going to have 4x squared y to the 12th power over 27 x to the 9th power y to the 6th power. You need to simplify this. The 4 and the 27 do not share a common factor other than 1. So keep it 4 over 27. Your x squared over x to the 9th, you're going to subtract those powers. Same thing with the y to the 12th over y to the 6th. Subtract those powers. This is going to give you 4 over 27 times x to the negative 7th power, y to the 6th power. That x to the negative 7th power has to turn into a positive 7th power, so it goes to the denominator of your fraction. The y to the 6th stays up top. So it's just going to give you 4 y to the 6th power over 27 x to the 7th power. For number 9, We have 3 to the power of 0, x to the negative second power, y to the fourth power, all raised to the fifth power, times 2x to the fifth power, y to the negative ninth power, all raised to the negative second power. So we're going to simplify what's inside the parentheses first. The 3 to the power of 0 is just 1. So cancel that out. You don't need it. The x to the negative second power is going to go to the bottom. The y to the fourth power is going to stay on top. It's still going to be raised to the fifth power. From there, you have 2x to the fifth power, y to the negative ninth power, all raised to the negative second power. So this is 2x to the fifth power over y to the ninth power, all raised to the negative second power. Flip the second fraction in order to turn the negative 2 power on it into a positive 2. So this is going to be y to the fourth power over x squared raised to the fifth power times y to the ninth power over 2x to the fifth power, now raised to the second power. Now apply your powers to both the numerator and the denominator of these fractions. The y to the fourth power raised to the fifth power gives us y to the 20th power. The x squared raised to the fifth power is x to the 10th power. The y to the ninth power raised to the second power is y to the 18th power. 2 to the second power is 4. And x to the fifth power to the second power is x to the 10th power. Because we are multiplying these, we're going to keep the base and add the powers. So y to the 20th power times y to the 18th power is y to the 38th power. And x to the 10th power times 4x to the 10th power is 4x to the 20th power. So it's just y to the power of 38 over 4x to the power of 20. For number 10, we have 5x to the negative fifth power, y cubed over 15x squared y, all raised to the negative second power. Simplify what's inside first. The 5 over 15 is the same thing as saying 1 over 5. Then you have, let's do it this way, 1 over 5. Then you have x to the negative fifth over x to the second. So we're going to keep the base, subtract the powers. Then it's y cubed over y. So again, keep the base, subtract the powers. So let's change this to be 1 over 3 instead of 1 over 5 so it's right. Okay, so 1/3 x to the negative fifth minus the second power, y to the third minus the first power, all raised to the negative second power. So this is going to become 1/3 x to the negative seventh power, y squared, all raised to the negative second power. If you want to turn this into a fraction, so it makes a little bit more sense, do so. This is going to give you x to the seventh power on the bottom, y squared is going to be the only thing on top. So it's going to be y squared over 3x to the seventh power, all raised to the negative second power. You got to turn that negative 2 into a positive 2. So take the reciprocal of that fraction. You're going to have 3x to the seventh power over y squared, all raised to now the positive second power. So we raise each the numerator and the denominator to the power of 2, and this is going to give us 9x to the 14th power over y to the fourth power. So the next part of your review goes over just performing the indicated operations. Before I start doing this with you, there is something on your test tomorrow that we went over between 3.1 or 5.1 to 5.3 that's not on your review. And it's standard form, the degree of your polynomial, the leading coefficient of the polynomial, and the name of it. So for example, if you had something like 37x to the second power plus 4x to the fifth power plus 2. Put this in standard form. Standard form of this would have the first power as your highest power in the line of your terms from left to right. So the first power would be 5 because that's the highest power, so that would give you 4x x to the 5th power. Then your second one is the 37, x to the 2nd power. And lastly, the 2. So that's in standard form. Let's do the leading coefficient first. Leading coefficient. The leading coefficient comes from the first term in the polynomial when it's in standard form. So the first term there is the 4x to the 5th power. The coefficient of that term is the 4, so your leading coefficient is 4. Next, you need to state the degree. The degree of the polynomial is the highest power in your polynomial. It comes from the first term in standard form. So the power of that first term in standard form is 5, so your degree is 5. Then you're going to have to tell if it's a monomial, a binomial, or a trinomial. Remember, a monomial is just one term. A binomial is 2 terms, and a trinomial is 3. You have 3 terms here, so this is a trinomial. Again, this is on your test tomorrow, but it's not on your review. So for the rest of these, we're just combining like terms or performing the indicated operation. We're putting our answers in standard form when we do this, okay? So for 11, we have 5x squared minus 3x plus negative 8x squared minus 2x plus 6. I'm going to get rid of these parentheses, so I'm just going to rewrite it without them. We're going to have 5x squared minus 3x minus 8x squared minus 2x plus 6. I'm just going to combine my like terms. My highest power is the x squared, and I have a 5x squared and a negative 8x squared. So we're going to combine those to get negative 3x squared. Then we have negative 3x and negative 2x. Those are like terms because they both share an x. The negative 3 minus 2 is negative 5. We keep the x attached to it. Lastly, we have one constant of that 6, so that gets just dropped down. So we have negative 3x squared minus 5x plus 6. For number 12, we have 5x squared minus 3x minus negative 8x squared minus 2x plus 6. So for this one, because the negative is in between the two sets of parentheses, we're going to distribute that negative into the second set of parentheses, and it's going to change the sign on each of those 3 terms. So it's going to give us 5x squared minus 3x plus 8x squared plus 2x minus 6. So now from here, just combine your like terms. You got your x squared with the 5x squared and the 8x squared. Those are like terms. It gives you 13x squared. Then you have negative 3x and positive 2x, which is just negative x. And lastly, you have that negative 6, which gets dropped down. So that's 13x squared minus x minus 6. For number 13, we have negative 5x cubed y times 2xy cubed. So remember with these, if you have a monomial times a monomial, you're going to multiply the coefficients together. Then you'll multiply your bases together. If they're the same base, you add the powers. So we're going to do negative 5 times the 2. Then we have x cubed times x, which is raised to the first power. We add those powers. Then y, which is raised to the first power, times y cubed. So we'll add those powers. The negative 5 times 2 is negative 10. X to the third plus the first is x to the fourth. And y to the first plus the third is y to the fourth. So it's just negative 10, x to the fourth power, y to the fourth power. Remember with these, if you are ending up with a negative power, it needs to be positive. So take the reciprocal of just the term that the power is attached to. For 14, we have negative 6x squared times 2x minus 3. So since we do have a monomial times a binomial here, we are going to distribute that negative 6x squared into that binomial and multiply it by both the 2x and the negative 3. So negative 6x squared times 2x gives us negative 12x to the second power plus the first power. Then the negative 6 times negative 3 is a positive 18x and that x squared gets dropped down. So it's just negative 12 x to the third power plus 18 x squared. For number 15, we have w plus 2 times w squared minus 2w plus 4. So we're going to start this one by distributing the w. So it's w times w squared, which is w to the third power. Then w times negative 2w is negative 2w squared. Then w times 4 is 4w. Next, we distribute in the 2. So 2 times w squared is 2w squared. The 2 times negative 2w is negative 4w. And 2 times 4 is 8. From here, combine your like terms. That w cubed, you do not have another w cubed, so just drop it down. Then you have negative 2w squared and positive 2w squared. Those are opposites of one another, so they cancel each other out. Next, you have the 4w and the negative 4w. Those are also opposites of one another, so those cancel each other out. The last thing that you have is that 8. So it's just w cubed plus 8. For number 16, you have 2 minus 3x times 4x minus 7. Now that 2 minus 3x is not in parentheses. And the only thing that's in front of the parentheses 4x minus 7 is the negative 3x. So this negative 3x is the only thing that's getting distributed into those parentheses. The 2 is going to stay the 2. So the negative 3x times 4x gives us negative 12x squared. Then the negative 3x times negative 7 is a positive 21x. If we put this in standard form, it's going to give us negative 12x squared plus 21x plus 2. Again, with these, your answers should be in standard form, which means the highest power should go to the far left, and based off of your powers from left to right, they should go from largest to smallest. For number 17, we have 2 minus 3x times 4 minus 7x, or 4x minus 7. We're going to FOIL this one out. So the 2 gets distributed in. So 2 times 4x is 8x. Then the 2 times 7 is negative 14. Then we have the negative 3x times the 4x, which is negative 12x squared. And the negative 3x times negative 7x, just negative 7, I'm sorry, it's positive 21x. You have like terms with the 8x and the 21x. That gives us 29x minus 14 minus 12x squared. If we're putting this in standard form, that 12x squared has to go down first, which is negative. So it's negative 12x squared, then the 29x, and lastly, the negative 14. So you'll realize with these, when I do put them in standard form, whatever sign is in front of them starting off stays in front of that term. For 18, you have 4a minus 3b squared. You can do this one of two ways. You can separate this to be 4a minus 3b times 4a minus 3b, and then FOIL it out. Or you can say to yourself, I have a binomial squared, and the sign that's in between the both terms that I have is subtraction, so I can use a squared minus 2ab plus b squared. Our a in this case is the 4a, and our b is the 3b. So we just plug them in. This is going to give us 4a to the second power minus 2 times 4a times 3b plus 3b to the second power. The 4a to the second power is 16a squared. The negative 2 times 4a is negative 8a times 3b is negative 24ab. And that 3b squared is 9b squared. So just 16a squared minus 24ab plus 9b squared. For number 19, we have 9a plus 5 times 9a minus 5. For these, your A is the same in both, your B is the same in both. However, they're opposite signs. So if you want to FOIL it out and then combine like terms, you could. If you didn't want to and you realize that your A's are the same in both sets of parentheses, your B's are both the same in both parentheses, and they're separated by opposite signs, you can use A squared minus B squared. So this is going to be 9a squared minus 5 squared, which is 81a squared minus 25. Again, you could FOIL it out, do 9a times 9a, 9a times negative 5, 5 times 9a, 5 times negative 5. When you combine like terms, you're still going to be left with the 81a squared minus 25. For number 20, we have a plus 5 cubed. So we can rewrite this as a plus 5 times a plus 5 times a plus 5. If you wanted to FOIL it out, you could. I know I have an a plus 5 times a plus 5. So that's just going to give me a plus 5 times a squared plus 2 times a times 5 is 10a plus 5 squared is 25. So from here, we can FOIL out the a, or not FOIL out, but distribute the a and then distribute the 5 into that trinomial. So this is going to give us a times a squared, which is a cubed. A times 10a is 10a squared. A times 25 is 25a. Then you have the 5 times a squared, which is 5a squared. 5 times 10a is 50a. And 5 times 25 is 125. If we add these, I just put my like terms on top of one another to make my life a little bit easier. We're going to have a cubed plus 15a squared plus 75a plus 125. For 21, we have a minus 3 to the 4th power. Now this one is the same exact thing as saying a minus 3 squared times a minus 3 squared. The a minus 3 squared, we know we can do a squared minus 2 times a times b plus b squared. And that's going to give us a squared minus 6a plus 9 times a squared minus 6a plus 9. From here, we're just going to distribute the a squared into the trinomial, then the negative 6a into that trinomial, then the 9 into that trinomial. So the a squared times a squared gives us a to the 4th power. The a squared times negative 6a is negative 6a to the 3rd power. A squared times 9 is 9a squared. Then we do, so you're going to now distribute the negative 6a into the second set of parentheses. So it's going to be negative 6a times a squared, which is negative 6a cubed. Then negative 6a times negative 6a is a positive 36a squared. Then negative 6a times 9 is negative 54a. From here, you're going to do the 9 now. So 9 times a squared is 9a squared. The 9 times negative 6a is negative 54a. And 9 times 9 is 81. So now we're just going to add our like terms. So the a to the 4th power drops down. Then we have negative 6a cubed minus 6a cubed, which is negative 12a cubed. Then 9a squared plus 36a squared plus 9a squared gives us positive 54a squared. Then the negative 54a minus 54a is negative 108a. And then we add down that positive 81. So we just have a to the 4th power minus 12a cubed plus 54a squared minus 108a plus 81. For 22, we have x plus 2 times 3x plus 4y minus 5. So this one we're going to start by distributing that x. So x times 3x is 3x squared. The x times 4y is 4xy. And the x times negative 5 is negative 5x. Then distribute the 2. 2 times 3x is 6x. 2 times 4y is 8y. And 2 times negative 5 is negative 10. If you look throughout all of your terms here, you do not have a common factor other than your x's. So combine the 5x and the 6x, and this gives you 3x squared plus 4xy plus x plus 8y minus 10. For 23, you have 3x squared times 5x cubed minus 2x squared plus 4x minus 5. We're just going to distribute in that 3x squared. So 3x squared times 5x cubed. Remember, multiply your coefficients, then add your powers if your bases are the same. So 3 times 5 gives us 15. X squared times x cubed is x to the 5th power. Then the 3x squared times negative 2x squared. 3 times negative 2 is negative 6. X squared times x squared is x to the 4th. That's negative 6x to the 4th power. Next, we'll do the 3x squared times the 4x. So 3 times 4 is 12. X squared times x is x cubed. And lastly, the 3x squared times the negative 5 gives us negative 15x squared. So that's 15x to the 5th power minus 6x to the 4th power plus 12x cubed minus 16x squared. For 24, we have 2x squared y times y squared minus 5y plus 7. So we're going to take the 2x squared y, multiply it by y squared. That gives us 2x squared y cubed. Then 2x squared y times negative 5y is negative 10x squared y squared. And the 2x squared y times 7 gives us 14x squared y. For 25, you won't have something like this on your test tomorrow, but so that way you see it done. You have 2x squared minus 3x minus 6 times 2x squared plus 5x plus 3. First, distribute the 2x squared in. So 2x times x squared gives us 2x to the 4th power. 2x squared times 5x is 10x cubed. Then 2x squared times 3 is 6x squared. Next, we'll do the negative 3x. Negative 3x times x squared is negative 3x cubed. The negative 3x times 5x is negative 15x squared. Then negative 3x times 3 is negative 9x. Lastly, we'll do the negative 6 into the x squared plus 5x plus 3. So negative 6 times x squared is negative 6x squared. Then the negative 6 times 5x gives us negative 30x. And negative 6 times 3 is negative 18. So we're just adding all of these. The 2x to the 4th drops down. 10x cubed minus 3x cubed is 7x cubed. The 6x squared minus 15x squared minus 6x squared. The 6x squared and the negative 6x squared are opposites. So it's just going to leave you with the negative 15x squared. Then the negative 9x minus 30x is negative 39x. And then you have that negative 18. So that gives us 2x to the 4th power minus 7x cubed minus 15x squared minus 39x minus 18.